Hello everyone, welcome to this class. This is just Simon taking you through IGCSE Extended Mathematics, paper 058022, May, June 2025. Question 1 is from symmetry. And part A, they are saying that we shade one more small square so that the diagram has one line of symmetry. This is a square. For any square, you know that we have this one is a line of symmetry. We have this one, we have this one here. This one is ugly. We have this one here, and then we also have that one there. There are 4. Okay, but then here we have parts which are shaded. So we have to shade one more square in here. Now, if we do like this, in order for this one to be a line of symmetry, okay, this part here has to be shaded. You see that? It has to be shaded such that this one falls on it. And then this one also has to be shaded. You see that? And then also, even this one has to be shaded so that this one will fall on it. Now, those are 3 more. So that one is not a line of symmetry. Let's go to this other one here. This one must fall onto this. So this one has to be shaded. Then this one here must fall onto this. This one has to be shaded. And again, this one here has to fall onto this. So even this one has to be shaded. So there we are shading 3 also. So that means this one cannot be a line of symmetry. But then if we continue, and now let's go to the diagonals. And I draw this one here. That one there. This one will fall onto this one onto this one, this one onto this onto this one onto this, then this one is shaded, will fall onto this one that is shaded, then this and this onto this one onto this. Now this one has to fall onto this one here. But now this one is not shaded. So if this one is shaded, then this one must be shaded. So that means we shall shade only one here, and then we have our line of symmetry. You see that? So this simply implies that the one that we are supposed to shade is this one here. That is that. How about this other one here? Let me draw another one. So this is the diagram we are given. Now suppose I draw another line of symmetry. Remember, these are diagonals. So this is the first one, then the second one has to be here. Okay, so what do we get here? Now, let's analyze again. This one will fall onto this one onto this one onto that. This one here has to follow this one onto this one, this one onto this one, this one onto this one, this one onto this one onto this one, this one onto this one. That means this one has to fall onto this one. So if this one is shaded, then even this one has to be shaded. So meaning the other one we are supposed to shade here is this one here. So either you are having this one here or this one here. You can shade here. And the lines of symmetry, I have put them for you there. The next part B, shade one more small square so that the diagram has rotational symmetry of order 2. Now, order of rotational symmetry is the number of times a shape remains the same as it is being rotated through 360 degrees. Okay, so let me write it here. So what do I mean by this? Suppose I have a rectangle. When I rotate it to 90 degrees, maybe clockwise, it will stand like this. Now it is not the same as this. That is 90 degrees. Then again another 90 degrees. Now it will come back and be like this one here. So that means after a half turn, that is 180 degrees, it looks the same as it was. That is 1. That means you will again rotate, then it will go to that, and again rotate 90 degrees, it will come back to that. That means order of rotational symmetry for the rectangle is going to be 2. This is 1, then this is 2. You see that? Now, when we come to this one here, it is a square, but it has gotten what? Some shaded squares there. So, since we see that here there are 2 shaded boxes, and here there is 1, that means we either shade this one or this one here. Okay, so suppose I shade this other one here, and then I have that. Okay, that means when I rotate to 90 degrees, then this one which is here will now come up to here. So it will be looking like that. This is how it will be. And then this one here will come here. That is 90. Is it still the same as how this one was given? No. Now, rotate again another 90. When you rotate again another 90, these two now will come to this. You see that? And then this one here will come to this. So after 180, we are seeing an order of rotational symmetry. So again, another 180, it will still give us. So therefore, I would come to this diagram here and I shade one more here, which will be this one here. As simple as that. Question 2 is coming from bearings. These are angles we measure from the North Pole and then we move clockwise. The scale drawing shows positions of 2 villages P and Q. The scale is 1 centimeter, which represents 0.5 kilometers. This means that 1 centimeter on paper is equivalent to 0.5 kilometers on ground. Find the actual distance between the village P and village Q. So you just get your ruler and you put here and you measure. Okay. So getting my ruler here, I can put it here on P. Then to Q here, you can see that that one gives me 9.2 centimeters. That's what I've gotten on my software here. So even you write what you have gotten, but since you all do the same paper, same printing out, that means you're going to get the same answer. Okay, so I will come to this one here and we shall write that PQ is equal to 9.2 centimeters, which is equivalent to 9.2 then times 0.5, because they want actual, that is in kilometers, and this one will be 4.6. But in a marking schemes, they have this one must be 4 point, no, this one has to be 8.8 centimeters. Your answer should be within this range. They usually don't give this range, okay, because they give you the same paper and you're supposed to come out with the same answer. And then of course this one times 0.5, you have to get 4.4. Then 2, this one will be 4.6. So I'm using this software, but still I've gotten one of the answers, which is 4.6. Now when you are printing using these other printers and you have gotten this paper, there is that command for fit to printer margins. So when you press that fit to printer margin, you are going to get this paper diminished by a scale factor. So that means the length you're going to get here, if you just print on your printer and you put fit to printer margins, the answer you get here might not be the same. But if you leave it as none, no fitting to printer margins, you might get the same answer, which is in the marking scheme. So these printers have a scale factor of enlargement, which affects the lengths, but the angles usually remain the same. Okay, that is similarity of figures. Then part B, measure the bearing of village Q from village P. Look at from. So you go to P, we are here, then you measure from the north, then to this line that connects P to what? To Q. Okay, so what do we have? You get your protractor here. Now you get your protractor, you put it at P, then you rotate it because we are supposed to measure from the North Pole, and then we go clockwise. Now this one has gotten two scales, but the scale I'm supposed to use is the one that begins with a 0 here, and then we move this other side. So you can see that it is the inner scale, you see, because this outer scale, its 0 is here, and then it keeps on increasing. So it goes anti-clockwise, and yet we are supposed to move clockwise. So this angle here, when you try to check here, it's 110. You see that? 110. Here they might give you some allowance because trying to fix this line of the protractor onto this North Pole here might be challenging to people. Okay, and also this arrow to balance it well might be challenging. So you might find that they give you some allowance, and they give you a range of the figures within which your value must lie. Now here they are saying measure the bearing. So from here it is 110. Now if it is 110, that is what I will write. Bearings we write to 3 digits. If you find that the one you get is below 100, let's say you get 75, you don't write 75 degrees, you write 075. Okay, so that is that. Question 3 is coming from angles, and these are parallel lines. So on parallel lines, we should be in position to recognize the alternate angles. This one is equal to that. Okay, we should also be in position to recognize what we call the corresponding angles. This one here corresponds to this angle here. Okay, as well as this one here corresponding to this one. Okay, and then also the interior angles, we add them, and then they give us 180. So this alpha plus theta should give us 180. Why? Just like you have seen, this is theta, and then this is theta, then alpha, alpha. These are angles on a straight line. So you might get something like this, and then this angle is here, and then maybe another one is given. So you just add these two and equate to 180 degrees, as simple as that. First, we shall also look at opposite angles. So this one here has to be 45 degrees, and this one here will be 65 degrees. You see that? So how do I get x here? These are angles in a triangle. So that means x is going to be equal to 180, then minus 45 degrees, then plus the 65 degrees. So this is 180, then minus what do we have here? This is 110, and of course this one will give us a 70. So x is therefore 70 degrees. Sometimes they ask for geometrical reasons. Here they have not asked for them, but these are the ones. Number one, we have opposite angles. I've used that property. So we have opposite angles are equal. Okay, then what else? Angles in a triangle sum up to 180 degrees. Angles in a triangle add up to 180 degrees. Now how about y? Now when you look at y here, this is 65. It corresponds to this one here. So I'll have 65 here. But also, do you see that it is an opposite angle to y? So y will be equal to 65. So the two that I can use here maybe are the properties. We have corresponding angles. Corresponding angles are always equal. Okay. Then next, we have opposite angles are also equal. You see? Question 4, we are given number cards here. They are saying Samina picks one of these cards at random and replaces it. Find a probability that she picks an odd number. So when you pick with replacement, the probabilities do not change. So when you pick, you see the number, then you put it back. Again, you put the probability of again picking, that is still the same. But if you pick without replacement, the totals are going to be reducing. So probability of picking an odd number, we know that an odd number is the number you divide by 2 and then you get a remainder of 1. So we have a 1, we have a 3, we have a 5, and we have a 7. Those are 4 out of the 7 cards we have. So this will be 4 out of 7, as simple as that. And then part B, Samira repeats this 35 times. Calculate the number of times Samira is expected to pick an odd number. So expectation is given by NP. So the number of times you have done the experiment, then times the probability of getting that success. So this 7 goes here 5 times. So 5 times 4, you get 20. As simple as that. Question 5 is coming from transformations. And in transformations, we look at 4 in IGCSE. We have translation, we have reflection, we have enlargement, and then rotation. So translate the triangle by the vector 0, -2. Remember, this is the x movement, and then this is the y movement. So y is positive up, and then is negative down. So if it is negative here, that means we are moving downwards. And then if the first number here is positive, then we are moving to the right. If it is negative, we are moving to the left. So since it is 0, that means we are not moving anything to the right or to the left. So that is 0. So in other words, we just move 2 units downwards. As simple as that. So this one here, this is 1, then 2. The same with this, then this one also comes here. So you have this point here, this one here, and this one here. Then you get your ruler. Please use a ruler, don't use your free hand when you are doing such numbers, because you can see that the triangle has straight what? Edges. If you want, you can even shade it. If you don't want, it is not a crime. Okay, down there, and then you can even label it that this is part A to become so smart. Okay, then next, part B, describe fully the single transformation that maps triangle T onto triangle U. Now, I have already said that when it comes to description of the transformations, always look at the marks given here. If you see 3 marks, think about rotation, where you can say this is rotation, that is 1 mark. Then give us the angle and the direction, maybe through 90 degrees clockwise. Is it clockwise or anti-clockwise? And then the center. So those are the 3 marks. You have rotation, you have the angle and its direction, and then the center of rotation. And then the other one is enlargement. For enlargement, you have to tell us that it is enlargement. That is the first mark. The second mark, the scale factor of enlargement, and then the center of enlargement. Those are the 3. But then where we have the 2 marks here, it is either reflection, where you tell us that it is reflection in the mirror line, you give the equation of the line. And then the other one is translation. You say translation by vector, just like this one, and you're done. So this is 1 mark, and this is 1 mark for that. So always look at the number of marks they give you, exactly what you're supposed to do. Now, since these are 3 marks, then we think about rotation and enlargement. But then if it is enlargement, that means the object and the image are of different sizes. But now when we look at T and U, they are the same size. In other words, they are congruent shapes. That means this one is rotation. So I will put down here rotation through, we need to know the angle. Now look at this side here, it is standing like this. Okay, then look at the corresponding side, it is this one here, it is standing like that. Which angle do they form? 90 degrees. That is how you get the angle straight away. So I'll say this is through 90 degrees. Is it clockwise or anti-clockwise? Let's check. If I take this one clockwise, then this one here will be like this. Then this one, which was standing like this, then it will fall like that, and then like that. So when you look at this and this, are they the same? No. So that means that one wasn't what? Yeah, it wasn't clockwise. How about if we go anti-clockwise? If we go anti-clockwise, this one here will be standing. Then this one here now will fall to this other side, and then this one like that. Don't you see that it resembles this one here? So it is anti-clockwise. So I will say this is rotation through 90 degrees, anti-clockwise. Anti-clockwise. Then you tell us the center. What is the center of enlargement? This one we get it by construction. Now 90 degrees anti-clockwise is the same as saying 270, because when you add these ones you get 360. So if you turn 90 this way, it is the same as turning 270, and then you come there. You see that? All right, so 270 clockwise. So you can say this one or this one. Okay, so we need to find the center. So to find the center, we are going to construct perpendicular bisectors of 2 lines, joining the object points to the image points. Then where they meet is the center of enlargement. Let me write this down. Construct 2 perpendicular bisectors. Perpendicular bisectors joining object points to their corresponding image points, where they meet is the center of rotation. So this one here corresponds to this one here. So I can begin with that. Get your ruler, draw a line. You can actually make this one dotted such that it doesn't interfere with the other line which you're going to, the perpendicular bisector you're going to draw. Okay, now get your compass, you press it here, this part, make sure that it goes beyond the midpoint of that line, because if it doesn't, then the arcs are not going to meet. So this one is already beyond, or if you want, you can make it reach here. Okay, you can make it reach here, but usually I don't like doing that because sometimes it gives you a bigger, the radius becomes very big. Okay, so you put it up here, you draw an arc. Okay, then without tampering with that compass, come down here, you also draw an arc. Okay, don't tamper with that compass, just shift it, then you put it here, And then you also do the same. You draw an arc up and then an arc down. Okay, then we draw an arc up here. Don't tamper, just bring this other side. Then draw that. Then from there, you get this one here. You connect those two arcs where they are meeting. Okay, that is the first one. Then the next one, I can use this one here and this one here. There's also another. So just get my compass again, then place it here. Oh, it disappeared. I'll place it here. Then it is already beyond the what? That midpoint. Okay, but remember, we are supposed to make this line dotted just like the other one, the blue one. Then I'm using these different colors such that you can see the lines properly. In the exam, you're not going to use these different colors. You just use your pencil. So since this one is beyond the midpoint, I just bring this one up here. Okay, then I draw an arc. Then also come down this side. Okay, then I draw an arc here without tampering with the length of that compass. Then come and put it up here. Then you also do the same. So you draw an arc down, and then you also draw an arc up there. Sorry. There. So where the two arcs have met, you get your ruler and then you connect just like that. Now where the two lines meet, you see that green one? And then the blue one. You see where they are meeting? Here, 2, 2. That is the center of rotation. So I will write that my center here is 2, 2. As simple as that. So there is a mark here. There is a mark here. And there is also a mark here. Those are the three. Question 6 is coming from algebra, and we are supposed to solve this equation. So part A, of course, to solve equations, we undo operations. So the addition is undone by subtraction. So subtract a 7 here and also this other side. So that means we shall have 8x, which is equal to 39 minus 7. And this one gives us 32. So how do we get x from here? Since this one is a multiplication, to undo multiplication, we divide. So 32, divide all through by 8, then this one gives us a 4. And then here, this is multiplication. To undo the multiplication, you do division. So we shall have 5y minus 1, which is equal to 24 divided by 2. Or you can begin by opening the brackets. So 5y here minus 1 is equal to 12. Take the 1 here. And 5y becomes 12 plus 1, which is a 13. That means y will be equal to that 13. Then we divide by 5. You write that answer 13 over 5. You don't have a calculator. This is the same as 2.6? Yes, 2.6. But if you don't know the decimals, please just leave it there like that. Or you can write it as a mixed number. And you say this is 2 whole number, then 3 over 5. See that? Okay, so I was talking of the alternative approach. You would say alternatively, you would say open the brackets here. You'll get 10y, then minus 2, which is equal to 24. Take this one here. It will add up to the other. So you have 10y, which is equal to 24 plus 2. And then y becomes, this will be 26, then divide by 10. Then you say divide by 2, divide by 2. Now you see what you are doing at last is what I did at first already. So divide all through by 2. Then this one will be the 13, then over 5. And since they never say that you put your answer, you give your answer in the simplest form. Again, when you write 26 over 10, they will give you that, or you can easily see that this is actually 2.6. You see that? Question 7 is coming from sequences. They are saying these are the first 4 terms of the sequence. We can see that here they subtracted a 3, even here, even here. That means for us to get the next term as part A, we shall get this 2, then we subtract a 3, which is a negative 1. And then they want us to find the nth term for part B. So since this one is a linear sequence, okay, what do we mean by linear? There is a common difference, okay, some common difference. So this one is going to be equal to A, then plus n minus 1 D, okay, where A is actually the first term of that sequence, and then D is the common difference. How do you get the common difference? You just get the preceding term minus the preceding term. Like you get the second term minus the first term, a third term minus the second term, like that. So the first term here is 11, then n minus 1. The common difference is negative 3. I always see students writing this. This one, when you write like this, yes, we know you are multiplying by negative 3, but now here it looks like another operation, like minus 3. So always put times, if it's a negative, put that one there. Then open the brackets, that will be 11. So negative 3 times n, that will be minus 3n. And then negative 1 times negative 3, then you get a positive 3. Now 11 plus 3, that one gives us a 14. And then minus 3n, as simple as that. There are also some other 2 methods we can use to solve this, but because of time, I'll just use this simplest one here. Then question 8, they are saying find the highest common factor of 36 and 54. There are 3 methods here we can use, but I'm just going to show you 2 because of the time. Number 1, get that 36 and then the 54. Then you divide through by a number that can divide both of them, okay? So by 2, this one can give us 18, and then this one 27. Now 2 cannot divide both, we can go to a 3. This one will be a 6, and then this one will be a 9. Again, a 3 can divide 6, and then we can get 2, and then here 3. Now there is no number that can divide these 2 except 1. So from there we are done. Then after that, to get the highest common factor, we just multiply all of these ones, these numbers that have divided these numbers, okay? So highest common factor is going to be equal to 2 times 3 times 3. 2 times 3, that is a 6. 6 times 3, that is 18, okay? Alternatively, you can find all the factors of those numbers, okay? Like the factors of 36 and then those of 54. So 1 times 36 will give us that 36. Then 2 times 18 will give us that 36. Then what else? 3 times what? 3 times 12. Then 4 times 9. But 36 is a square number. So 6 times 6. That means when I'm writing the factors, I move like that. So factors of 36 will therefore be equal to, we have 1, 2, we have 3, we have 4, we have 6. Now this one is a square number, so you have 6 times 6. You don't write 6 and then 6 here. No, you just write 1, 6. Okay. Then we have 9. When you go up, then we have 12, then we have 18, and then 36. Then 54, we have 1 times 54. Then we have 2 times 27. Then we have 3 times 18, yes. and then 6 times 9. Then that means we can have factors of 54. Those ones are 1, 3, 6, 9, 18, 27, 54. By the way, one thing you need to know is that a square number has an odd number of factors. Like this one is 36. You can see that this one is just 6 times 6, so it is here. These are 4 plus 4, 8. Then with this 6, so those are 9. It is an odd number, okay? And then when you look at this one, it is not an even number. I mean, it is not a square number, so it is the factors which we get here must be even. 2, 4, 6. Oh, I think I skipped something here. There is a 2. Now you can see these are 2, 4, 6, 8. It is an even number. Okay. All right. Now the common ones, we have this, we have 2, we have 3, we have 6, we have 9, and then 18. But which one is the highest? Is 18. So that's why our highest common factor is 18. But I would recommend this one here, okay? Because if you miss out on some factors in here, you might get it wrong, okay? So that is that. Question 9 is coming from vectors. They're saying A is a point, 3, -1. AB is 2, -4. Then AC is twice AB. Find the coordinates of C. Now, if I have points A, let's say A is here, and then C is here, then I have O here. It's the origin. So we can have OA, then OC. So if I want to get A to C, then I will say AO, then plus OC. But since these ones are opposite directions, then AO is the negative of OA. You see that? So in other words, I will have AC is equal to AO plus OC. You see? Negative of OA and plus OC. But usually what I say is that get the last one minus the first one. So if it is AC, you just say OC minus OA. The last, then minus the first one. As simple as that. Okay, so let's come to this one here. We have AC is equal to twice AB. This is OC minus OA, which is equal to twice of AB. I don't need to split this one because we have the AB. So OC is therefore going to be OA, then plus twice of AB. Now OA is 3, -1. Here it is given as a point, coordinates, but its position vector, you just make this one column, then plus 2 times AB, which is 2, -4. So we shall have 3 here, then plus, this will be a 4, and then -8. You add the corresponding entries. So this one will give us a 7 and then a -9. So meaning the coordinates will then be 7, then -9. Part B, the length of AB is k root 5. Find the value of k. If I have a vector here, and maybe that is A, that is its magnitude, there is movement in the x direction, and there is movement in the y direction. This is x, this is y. So using Pythagoras theorem, then A squared shall be equal to x squared plus y squared. So meaning the magnitude of A will be the square root of x squared plus y squared. So even here, AB, the magnitude of AB, or the length of AB, is therefore going to be, remember here we have 2 and then -4. So it's the square root of 2 squared, then plus -4 squared. Root of 4 2 squared is a 4. 4 squared is 16. When you add these two, you get 20. 20 is the same as saying root of 4 times root of 5. But root of 4 is a 2, then root 5. Now, what is k? Don't you think it is 2? So k is therefore 2. And then part C, P is a point on AB, and they are saying that AP to PB is 1 to 3. So this is A, and then this is B. Now from here, you can see that AP, we can use fractions. Ratios can be turned to fractions. AP out of PB will be equal to a third. That means when you cross multiply, 3AP is equal to PB. That means P can be here, okay? And then 3 of AP, they are in this AB. Now they want a position vector of OP. So, do we have B? We don't have B, right? The coordinates of B, because I would have used this one is OP minus OA, this is OB minus OP, but we don't have B. So what I can do is to use AB, which I'm given. So AB is actually equal to AP, then plus PB. But remember that PB is 3 times of AP. So I can say 3 AP. That means AB is 4 times AP. Or you would say AP is 1 over the total, 1 over 1 plus 3, then of the total from A to B. As simple as that. So meaning AP is a quarter. AP is a quarter of AB. So this one is going to be a quarter of AB. AB we are given, it is 2 negative 4. 2 negative 4. And of course here you get 0.5. A quarter of 2 is 1 over 2, so which is 0.5, and then this one is negative 4. Then from there, AP, just like I said, we forget the last minus the first. So it will be OP, then minus OA. So bring this on this side, that means OP is going to be AP plus OA. So OP is equal to AP plus OA. What is AP? 0.5, negative 1. What is OA? We have 3. Was it 3 negative 1? Yes, 3 negative 1. Now 3 plus 0.5, of course you get 3.5, not so? So you have 3.5, and then negative 1 plus negative 1, you get negative 2. Question 10 is coming from circle problems, and they're saying that the diagram shows a sector of a circle center O. The length of the arc is n pi, and then we are supposed to find a value of n. Now, length of arc is equal to the angle it subtends at the center of the circle. This arc has subtended 45, okay? Divide by the angle sum of the circle is 360. Just like you know, angles at a point add up to 360, okay? Then times the arc here is part of the circumference of that circle. So we multiply by the expression for the circumference of the circle, which is 2 pi r or pi d. But you know that the diameter is twice the radius, so that's why we have 2 pi r. Okay, then what else do we have here? So this theta is 45, divide by 360, then times 2 pi, then the radius is 18. Now, this is 45 times 2, which is a 90. So I'll have 90 over 360. 90 goes into 364 times, you see? So we shall have a quarter, then times, we have a pi here. Remember, I took the 2 in here to give me the 90. Are we there? Then times 18. By 2, you get 9. By 2, you have 2. So meaning you are going to get 9 pi out of 2. So n, it's the coefficient of the pi, so it is going to be that 9 over 2. Or you can write it as 4.5. But you write one of these two answers. Don't do like I've done, that 9 over 2 or 4.5. No, just write one. Then number 11. Question 11, part A, they are saying write this in the standard form. So in standard form, we must have something like this. A times 10 to power n. Okay? Where A has to be ranging from 1 to less than 10. You have 1 point something, 9 point something, but not like 10 point whatever, then times 10 to power whatever. You get it? Or even 11, maybe 0.2 times 10 to power, let's say 3. This one is not falling into this interval. In other words, we must have one significant figure on the left of the decimal point. So if it is here, there has to be here, okay, one significant figure. So I have to move, this is 1, 2, 3. Okay, that means I've multiplied this one by 1,000. In other words, that will be 7, then 0.08 times 10 to power 3. I moved to the right 3 what? Places. 3 places to the right. Okay, then when we come to this one here, we are supposed to give the answer in standard form. You are not supposed to change this one to an ordinary number. You are not going to write 38, then 22 zeros, and then here you write 38 and then 21 zeros. It will be wastage of time. Okay, so what you do, you either express this one in terms of times 10 to power 23, just like this one, or times 10 to power 22. Okay, but I recommend using the bigger one, that is 10 to power 23. So 3.8 times 10 to power 22, then plus 3.8 times 10 to power 23. This is what you do. First of all, this 3.8, we have to do something to it. But for this one to become times 10 to power 23, this one must be having times 10. Okay, we shall have something like times 10 to power 1, then also times 10 to power 22. Are we there? Such that when I add these two, I get a 23. Okay, now pulling out a times 10 power 1, that means this one will have to go this other side. Okay, then we shall have 0.38 times 10 to power 1. Because times 10 to power 1, then that means this one will go here. Okay, and then this whole thing will give us the 3.8 that you're seeing here. You see that? Then plus this other one is 3.8 times 10 to power 23. This one is a number in standard form. This one is not a number in standard form because remember here we are supposed to have one significant figure, and 0 is not a significant figure unless it is in between other figures. You see that? So I've done this one such that I can get a times 10 to power 23 common. So here I will have 0.38 times 10 to power, add these ones, 23. Then the same thing here, 3.8 times 10 to power 23. Now I keep this one outside. Times 10 to power 23 is common. Okay, so here I have 0.38, then plus 3.8 here, then times 10 to power 23. Now 3.8, then add 0.38. I'll put a 0 here, then this will be 8. 8 plus 3, you get 11, put 1 here, take 1 here. So that will be 4.18, then times 10 to power 23, and that becomes our answer. Question 12 is coming from circle theorems and properties. PQ and R lie on a circle. QR is a diameter. Find the angle PRQ. Give geometrical reasons for your answer. Now you see, here they are asking us of the geometrical reasons. Now, if this one is a diameter, we know that angle in the semicircle is always 90 degrees. So this one is 90 degrees. But also this property here stems from this one. Okay, I have the two radii here. This is a point, this is a point here. And then there are these chords that are coming from this point here. Then there is also this chord here that comes back here. So it is known that angle at the center here is twice angle at the circumference. So if this is x, then this is 2x. So even here you can see that this is 180 degrees, just like we can have this, okay? And then we connect this to that like that. But now this one has been put here, and then this one has come here. So the angle is what? 180. Then again from this point, then you go to the circumference and then to the Q. A half of 180 has to be what? 90. So that means if I have 90 here, then this angle and this one here must also give me another 90, so that when I add, I get 180, because you know that angle sum of a triangle is what? 180 degrees. So this means that angle PRQ shall be equal to 180 degrees, then minus 90, which is added to 74. Another person will just say 90 minus 74. Why? Because when you open the brackets here, 180 minus 90 minus 74, this one here gives you the 90. You see that? And then you get 90 minus the 74, which actually gives us 16, not so? Okay, so we shall have a 16, and that is the answer we are going to put here. So because then the reasons are going to be that angle in semicircle is 90 degrees. That is one. Then the other one, this property here, angles in a triangle sum up to 180 degrees. And they say geometrical reasons, that means it is not one reason. So the other one, I can say that angle sum of a triangle is 180 degrees, or you can say angles in a triangle add up to 180 degrees. It is the same. Question 13 is coming from statistics, and particularly this is grouped data. So part A, they are saying 100 students solve a puzzle. This is actually the summation of F. The table shows the information about the time taken by each student to solve the puzzle. Those who take between 20 to 40 seconds were 30, then 40 to 60 were 40, then 60 to 100 seconds were 30. And then they want us to find the mean. As Roman 1, we know that mean for grouped data is equal to summation of fx out of summation of f. So since we don't know the individual data values within these ranges, so we take an average of those numbers. So that is 40, then plus 20 divided by 2. That is what we call the mid value. That is the x here. So the frequency is 30. And then x is going to be the lower limit plus the upper limit divided by 2. And then the next one, we shall also do the same, 40 into, then 40 plus 60 over 2. And then lastly, we have 30, then times 60 plus 100 out of 2. Then from there, we divide everything by the summation of f, which is 100, or you can say 30 plus 40, 70 plus 30, that's 100. Now, 60 divided by 2, that is 30. That means we have 30 times 30. And then this is 40 times what? Isn't this 100 divided by 2? That is 50. Then we have 30 times, that is 160 divided by 2, that is 80. Then we divide by 100. This one is 900. 3 times 3 is 9, and then the 2 zeros. Then 4 times 5, that one is 20. Then you add on the 2 zeros. And then 3 times 8, that one gives us a 24. Then add on the 2 zeros, 0, 0, then out of 100. Now we have 2000, we have 2400, then we also have 900. So when I add, these are 2 zeros, and then this will be 13, then carry 1, that becomes a 5. So we have 5300 divided by 100. Of course, these 2 zeros will cancel, and then the answer becomes 53. As simple as that. Then Roman 2, complete the histogram to show the information in the table. You can see that on the vertical axis, we have frequency density. Now, before we draw a frequency, a histogram, then we are supposed to look at the class widths. If the class widths are the same, then we plot frequency here against the class boundaries, okay? But if the class widths are different, we instead use frequency density against the class boundaries, okay? Now, how do we get the frequency density? Frequency density is equal to frequency divided by the class width. So the class width here, you just get 40 minus 20, that will be 20. Then 60 minus 40, that will be 20. And then 100 minus 60, that is 40. So here we shall have the frequency 30 over 20, which will be 1.5. And then here, this will be 40 over 20, that will be a 2. And then 30 over 40, 33 over 5, which is the same as 0.715. Now, coming to this one to plot, you can see that this is 1.5. You see that? That is the first one, from 20 to 40. And then the next one is 2 from 40 to 60. So I'll just come to this. I draw this. Use a ruler, please. And that is it. You can even shade it or you don't. But since this one isn't shaded, I don't need to waste time shading this, okay? Then the last one is 0.75 from 60 to 100. So 0.75, that is 0.567. Then 75 is there. It has to be in the middle. So what we are going to do here is look for 0.65675. So in the middle there, in the middle of this, then you take it to this other side here, and then take it down. As simple as that. Part B, 80 students solve the same puzzle as the students. Part B, 80 adults solve the same puzzle as the students. The cumulative frequency table shows information about the time taken by each adult to solve the puzzle. And we are given cumulative frequencies. Remember, for cumulative frequency curve, we draw cumulative frequencies against the class boundaries. If we were given, for example, what we are having here, then this would be the first cumulative frequency. The second one would be 40 plus 30, because cumulative means we add, okay? All right, but here we have everything has been already added for us. So 20 and 0, 20 and 0, it is here. Then we have 40 and 12, 40 and 12, it is here. Then the next one, we have 60 and 36. 60 and 36. Then the next one is 80 and 60. 80 and 60. Then the next one, we have 100 and then 74. 100 and then 71, 2, 3, 74. So it is here. And then lastly is 120 and 80. So it is the same. It is just here. And then we join those points to produce a smooth curve. Don't use a ruler, okay? Use a free hand. So that is our smooth curve. Then from there, we can actually use this one to find the median, the interquartile ranges, the deciles, the percentiles, number of students or adults who did what, whatever. So a median is a number that divides the given distribution into two equal parts. So a half of the summation of f. Summation of f is what? So you just come here, you look at this, which is 80. So that is 80. So this one is going to be the 40th value. And then the lower quartile, a quartile is that number that divides the given distribution into 4 equal parts. So a quarter of 80 is in this one 20. So the 20th value. Now you go to your graph, you look for 20, you put a ruler, and then you draw, let it meet the curve, and then you go down. That is that. So that is our lower quartile, which is Q1. And this is 48 because one small box here, we can see that it is equivalent to, they are adding 10, 10 every now and then. So 10, then divide by, there are 5 small boxes within. So meaning that is 2 units. So 2 times the 4 that go beyond the 40, isn't that 8? So that one becomes 48. Okay, so I'll write my answer here as 48. And then the median, I go to 40. So 40 is here. And then go down. This is 64. 64. Then in the scheme, you find that here they expect you to get your answer within 62 to 64. So mine is 64, so I'm there. And then this other one here is from 46 to 48. And I've gotten 48. I've actually gotten extremes. Okay. So they give you this allowance because not all of us are going to draw the same what? Smooth curve. Okay. You might find that for you, when you are passing here, you come like this. You get it. Another one comes like that. So those small allowances help you to be within the range of the answer that is supposed to be marked. Okay. So thank you so much for watching. This has been the first part of the paper. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.